Okay, so discriminant, as of last lesson, we recapped that from topic 6, just what we went through, the discriminant idea came from basically the quadratic formula. When you have negative plus minus, square root b squared minus 4ac. So this b squared minus 4ac will give you three scenarios. So why is it discriminant? Because as the name suggests, it discriminates. It gives you the kind of answers that you get. The idea is to look at the discriminant, and if you look at the discriminant, you don't have to solve the equation. Just by calculating b squared minus 4ac, you can determine what kind of answers that you will get. Okay, so there are three cases. One is more than 0. So if it's more than 0, then you realize that you have two different answers. You have two different answers, and intersects the x-axis twice. Okay, if it's equal to 0, then the solution, right, is just negative b over 2a. And also it turns out it's the line of symmetry. Remember, x equals to negative b over 2a. Yes. Yeah? Whatever. Oh shit, sorry. Oh. Okay. I hope no one wants. Okay, so two distinct. Oh, sorry. Okay, so two equal real roots that intersect the x-axis once. Okay, or once. There's only one intersection. And the point where it intersects is also the line of symmetry. Okay, ma? Okay, now. So this one a is more than 0. This one a is less than 0. Happy face or sad face. If the discriminant is less than 0, then there's no real roots. No real roots because basically if the discriminant is less than 0, then when you square root a negative number, the square root explodes. So it cannot happen. Therefore, it doesn't intersect the x-axis. Sometimes when you see in question, they will tell you that it's always positive or always negative. Okay, this can also. Okay, so always positive doesn't refer to the discriminant positive. It means that your graph, the y value is always positive. This is sitting above the x-axis, it's floating above the x-axis, or sinking below the x-axis. Okay? Either way, either of this graph, you notice that because they never intersect the x-axis, there are no roots. Okay, I'm sorry I write small because I need the space here. Okay, okay, so with that, the last time round we stopped at question 1.4. We stopped at question 1.4. Okay, I just want to go through 1.4. Oh, anyone haven't do 1.4 yet? 1.4 yet? Haven't? Oh, okay, I don't know this one. No, I'll go through it. So, Xinhui, you all just watch the video from last week. You all have my channel, right? So it's the same. Won't miss out. So, if question 1.4 and 1.5 is what we call a show or a proof question. It's what we call a show or a proof question. Let me just go to 1.4 first. Okay, you cannot, okay, because you are asked to show, you want to show real and distinct roots. You want to show real and distinct roots. Okay, so what you cannot do, guys, is you cannot write this as your first step. You cannot write down discriminant more than 0 at the start. Okay, the moment you write this, got it, pass away. Okay, this is not because your concept is wrong, it's because your presentation, this is what you want to show. Okay, this is what you want to show. If you put want to show, I use short form now, okay, don't interpret other ones. Okay, so I want to show discriminant. Okay, if you just write this one is wrong. Okay, this one is wrong. Okay, because it's like this. Okay, prove that he is a murderer. First, the first hearing you straight away say he's a murderer. Okay, so there's no evidence. There's no evidence. Okay, if you want to show something, that proof or the conclusion must be at the last step. This guy needs to be at the last step. Okay? So it has to be at the last step. So you just check you're working and your body's working. Take note, if it's a proving question, the teachers are very particular about the order of presentation. So you cannot write down discriminant. So you need to write something like this. Okay, so for example, you just write the discriminant. Okay, write the discriminant as an expression. Write the discriminant as an expression first. I do not assume any value. So the discriminant equals to negative q squared. I think I'm sure you all can do get 3 is equals to q squared minus 36. Yeah. So this is how you present as an expression, not equation, as an expression. Okay, so you cannot write down the discriminant more than 0 at the start. Okay? So then after that you would, if Q more than 6 as given by the question, if Q is more than 6, then you can say that discriminant equals to Q squared minus 36. Of course 36 minus 36 will be more than 0. So this is the last step. If they ask you to show or prove, the moment they ask you to show or prove, then that show or prove must be in the last step. It must be in the last step, the final step. Okay, ma? Can I? Okay. So with that, I think, I'll just give you all some time to do 1.5 to 1.7. 1.5 to 1.7. Let me pause. Can pause or is it a